We want to talk now for week 9 about simplifying complex rational expressions. If you look at this example here, I hope you can see the difference between this and the division questions we were doing earlier. When we're dividing, we have a single denominator. In this question, both the numerator and the denominator have two terms. So we need to deal with that. And I've given you some steps here in the notes to do so. The first step is to bracket the numerator and the denominator. We do this to remind ourselves that these belong together. Now we can see we have a division question, the numerator divided by the denominator. And in fact, the next step suggests that we can write this as a horizontal division question. If you know how to solve this as a vertical division question, you can go ahead and do so. But if we solve it as a horizontal division question, we'll be doing it the same way we did all of our other division questions. So we have the numerator divided by the denominator. And notice that I've left some space in the brackets. Now these brackets are important. If we didn't have these here, then order of operations tells us this would be a very different question. What we would have is the division first, and then the addition and subtraction. So we want to be careful and make sure that we keep the brackets for the numerator and the denominator. The next step is to write each bracket over a common denominator. This is just the adding and subtracting that we were just doing. Adding and subtracting rational expressions. Find the lowest common multiple of the denominators, multiply by the missing factors, and then simplify. So if we look at our first bracket, we see that the lowest common multiple of the denominators is 5x. And we know that in order to add, we have to multiply each term by the missing factors. So we have x minus 5 all over 5x. Can you write the second bracket over a common denominator? Try pausing the video. Our common denominator is going to be 10x squared. We have x squared, x squared missing from the first term, and 10 missing from the second term. So the numerator here is 7x squared plus 10. Now we can change this to multiplication by the reciprocal. So when we're dividing with rational expressions, just like dividing with fractions, we keep our first fraction the same. Division becomes multiplication, and then the reciprocal of the second expression. Remember that you always want to simplify before you multiply. There's nothing to factor in this question, but I do see that 5 is common. It divides into 5 and 10. And I have a factor of x, 1x here, leaving only 1x in the numerator there. So my numerator is 2 times x minus 5 all over the denominator, 7x squared plus 10. This would be our answer in factored form. If factored form is not asked for, you would need to open those brackets using the distributive property. So both of these are fine. Why don't you pause your video and see if you can try the next one. So if you did step 1, you bracketed the numerator and the denominator. And then step 2, you wrote this as a horizontal division question. Now we want to write each bracket over a common denominator. We see for our first bracket, it's going to be 2xy. So we're missing factors, missing 2x for the first term and y for the second term. So we have 2x squared plus 3y all over 2xy. If you haven't written the second term, the second bracket over a common denominator, pause your video and give it a try now, remembering, of course, that y is over 1. Our common denominator will be 2. There are no factors missing from this term, so I don't need to multiply it by anything. But here, we're missing the factor of 2. So we have x plus 2y all over 2. Now we can change this to multiplication by the reciprocal. And we're looking for common factors. Remember that factors multiply each other. There's nothing to factor here in this numerator or this denominator, but I do see that 2 is a common factor that can be divided out. So in the numerator, we have 2x squared plus 3y all over xy times x plus 2y. This is our answer in factored form. If you're not asked for factored form, you'll need to open those brackets. Either of these could be your final answer. One last question to try here. Why don't you pause your video, see if you can do it. So you bracketed the numerator and the denominator and then wrote this as a horizontal division question. You may have noticed that in that first bracket in the numerator, it already has a common denominator. So this could have been written as m plus 2 over m minus 2. And the second expression, the denominator, already is over a common denominator. So these brackets weren't really necessary. So we can change this to multiplication by the reciprocal. And now, of course, before we multiply, we want to simplify. And we see there is some factoring that we can do. We have a difference of squares and a greatest common factor. And now we have factors that can be divided out, m plus 2 and m minus 2. So this simplifies to m plus 2 all over 2. I wanted to talk about why we're not using brackets in this second step. Brackets aren't necessary here because we have a single expression multiplying a single expression. The brackets don't add anything, don't give any extra meaning to the question at this point. It's just here where we have addition that needs to be completed before the division that those brackets are important. Use brackets when they're needed, because when we're verifying your test or your exam, those brackets are worth marks. Be careful about that. Now we want to talk about solving rational equations. We did solve some basic equations that had fractions in them, but we haven't worked with x or another variable in the denominator. And I don't want you to get mixed up with addition and subtraction. If you think back to adding and subtracting rational expressions, we kept the denominator. Now, when we're solving rational equations, we want to remember that we're going to get rid of the denominator. So the first step is to factor the denominators and find the lowest common multiple of the denominators. This is the same as adding and subtracting. But now it's going to be a little bit different. Now we're going to multiply both sides of the equation by the lowest common multiple, not by the missing factors. We're multiplying by the lowest common multiple. When we do this, it's going to get rid of the denominator. So this is the step that gets rid of the fractions for us. Make sure you use the distributive property and then solve for x. We do need to be sure that we're checking for restrictions. So whenever you see x or another variable in the denominator, make sure you check for restrictions. Remember that the denominator cannot equal 0. Let's use these steps with some examples. This one's like the type of question we've done before, just numbers in the denominator. We see that the lowest common multiple of the denominators is 10. So we're going to multiply each side by 10, remembering on the left that we need to use the distributive property. 10 is going to have to multiply every term. So now when we simplify, you can see that the fractions are gone. 10 divided by 5 is 2. That gives me 2 times x minus 3. I have a plus sign here. 10 divided by 2 is 5 times x minus 2. 10 divided by 2 is 5 times 1. In one step, the fractions are gone. I know that some of you have learned to do this differently, and I don't mind as long as your math is shown correctly and you get the correct answer. However, what I find is it's very difficult because you have complicated fractions for a long time. If you look at this, there are no fractions. Now we can just use the distributive property to open our brackets. Remember, I always want you to simplify. So on the left, we have 7x minus 16. Now we can add 16 to both sides and divide by 7. X is not in the denominator of this question, so there are no restrictions. That means that x equals 3 is our solution. Let's look at question 2. We have an integer over 1. The other denominators are a minus 3. That means the lowest common multiple of these denominators is just a minus 3. So we're going to multiply each side by the lowest common multiple. Notice that this time I have the lowest common multiple in brackets. That's because it's a binomial, more than one term. And again, we're going to need to use the distributive property here. So we have a minus 3 times 2, a minus a minus 3 times 3 over a minus 3 equals a minus 3 times a over a minus 3. We can use the distributive property here. A minus 3 divides out, so we have minus 3. A minus 3 divides out equals a. We can add 9 to both sides, subtract a from both sides, and we find that a equals 9. Because there is a variable in the denominator, we need to check our restrictions. We see that a cannot equal 3, because 3 minus 3 would give us 0. But a equals 9. This is our solution. Let's talk about question 3. I know some of you learned that you would cross multiply here, and that's fine, but I'm not going to talk about it that way because I like to do the same thing every time if possible. There's nothing to factor in these denominators, but I can see that the lowest common multiple is going to be 6 times m minus 4. I want to multiply both sides by 6 times m minus 4. Now I see that m minus 4 divides out. I have 6m equals, on the other side, 6 divides out, and I'm left with m plus 4 times m minus 4. So we have 6m equals m squared minus 16. This is a quadratic equation. We have m squared. And the only way that we've talked about solving quadratic equations is by factoring. And we said before you can factor, it has to equal 0. So I'm going to subtract 6m from both sides. Why don't you pause the video and finish this question? That means you needed to factor. And using the zero factor theorem, we know that m minus 8 could equal 0, or m plus 2 could equal 0. So we have two possible solutions, m equals 8 or -2. Because m is in the denominator, we do need to check our restrictions. So when we look, we see that there is one variable, one m, in the denominator. And we see that m cannot equal 4, because 4 minus 4 would give us 0. Each of these are a possible solution. If MyMathLab asks for you to separate your answers with a comma, it could be written like this. So another question for you. What I'm going to suggest is that you pause your video, work as far as you can, turn it on, check what you've done, pause again, see if you can get yourself through this question. The first thing you needed to do for question 4 was find the lowest common multiple of the denominators. To do that, you needed to factor the first denominator. Now we can see that our lowest common multiple is r plus 7 times r minus 2. Remember that we want to multiply both sides of the equation by the lowest common multiple. Now on the right side, we can simplify this right away. We see that r minus 2 divides out. On the left, I'm going to write this out the long form. You don't necessarily have to, but I want you to see what's happening. So we have our lowest common multiple times the first term plus the lowest common multiple times that second term equals, and then we have 1 times r plus 7. So let's fill in the rest of that question. So here we have 4r minus 4 over r plus 7 times r minus 2, and here 2 over r plus 7. So you see, all of this divides out. We're left with 4r minus 4. Over here, r plus 7 divides out, and we're left with plus 2 times r minus 2 equals r plus 7. Let's simplify this right side. Now I can subtract r from both sides, add 8 to both sides, and we see r equals 3. We do need to check our restrictions. There are two factors that contain r plus 7 and r minus 2. That tells me that r cannot equal -7 because -7 plus 7 is 0. R cannot equal 2 because 2 minus 2 gives me 0. I have the solution r equals 3. It's not a -7 or 2, so we can keep our solution. Another question for you. Again, pause the video, see how far through this question you can go. So you factored the denominator there in the middle. You found the lowest common multiple of the denominators is x plus 3 times x minus 2, and you multiplied both sides. We can go ahead and simplify on the left here. So we're left with 2 times x plus 3. And on the right, I'm going to write it all out for you. Let me just pause the video and write it. So we can simplify on the left using the distributive property. We see here the denominators divide out, and we're left with x squared plus x. And here, x plus 3 divides out, and we have x minus 2 times x plus 2. Now, this is one of those tricky questions because we are subtracting. That means we're going to need to subtract this entire product. Have I mentioned that on your test or your final exam that you will likely get a subtraction question, not addition? So we have 2x plus 3 equals x squared plus x minus that difference of squares. Once we open our brackets on the right, x squared plus x minus x squared plus 4. This gives us 2x plus 3 equals x plus 4. Let's finish it over here. I have some room on the side. Subtract x from both sides. Subtract 3 from both sides. We see that x equals 1. Of course, we want to check our restrictions. And I have x, 2 factors with x. We see that x cannot equal 2. Oh, I guess I didn't get rid of that. And x cannot equal -3, but it doesn't. X equals 1, so this is our solution. One more question here for you. Why don't you pause your video and give it a try?